got 2 times negative 4 plus 3 times 2. And definitely show all the work here. Yeah, don't just count on not missing a negative or something. You never know. We should get negative 2 for the first. And over here, a g of negative 2, right? You end up getting 1.5. Oh, negative 1. Yeah, h is negative 1 times f of negative 3. H of negative 1 is the 1.5 times 4, or negative 4, which gives you the negative 6. So as these get more complicated, you definitely have to have a structure to your work. So especially if you're doing this on free response questions, you have to show all the little steps and everything. So don't leave anything off here. Always have the work there. All right, now let's look at an absolute value. So this is part C of the same problem, so we're still using the table up here. So find out what f of g of 0 is. Right. And then we're just going to set that equal to the absolute value of 3x minus 4. Whatever this answer is. Now g of 0 is 1, I heard. Yep. And f of 1 is? F of 1 is 4. So we want to know where this absolute value equals 4. Now, let's take you back because maybe you haven't solved absolute value in a while. Let's find... that was the homework. Where's the other one? Yeah, so if I graph just the absolute value of 3x minus 4, obviously it's a V shape, it's absolute value, right? And if I want to know where it equals 4, graphically that's where these lines intersect. So you can see there clearly should be 2 answers. So when you're doing this algebraically, you should have these 2 x values. One is like 0, and 1 comes out to 2.6 repeating. All right, so how do you do that algebraically as a reminder? So there's 2 numbers that I could take the absolute value of that let me get an answer of 4. So if I want to get an answer of negative 4 here, right? Absolute value of negative 4 is 4. So I want to know where 3x minus 4 equals negative 4, right? But I also want to know, well, when does this equal positive 4 right here? Because if I have the absolute value of positive 4, that also equals 4. So that's where the 2 answers come from. Because there's 2 numbers I can plug in that give me the same answer of positive 4. So then when you solve those separately, right, add 4 to both sides, you get 0. 3 times what is 0? Just get x equals 0. So that's where that first intersection comes from. And then lastly, we'll have 3x equals 8. And therefore, x equals 8/3, which is the same as 2 2/3, which is the same as that 2.6 repeating. Okay, so we usually just leave it as 8/3 though. So we're just expanding everything a little bit, but nothing we can't handle. All right. All right, next let's look at graphing transformations. You must remember some of the stuff from geometry for transformation. Remember all the translations, rotations, reflections, and everything? Yeah, it's a lot of that today. So if I look at number 8, a little reminder here. Oh, no, don't need that K there. All right, so there's our basic parabola, right? It has a value in front. We have a number being subtracted on the inside and a number being added on the outside. Do you remember what these values actually do to the graph? So if I change h, do you remember what that does to the graph? And then everybody knows? Yeah, left and right. Bounces left and right. Okay. So it's a translation left and right. So I would say that mathematically. What does the K value do? Translation up and down. Good. There you go. Hours of entertainment right there. Just staring. And then what does the A value do in front? Yep. Well, this is the flappy part. Yeah, it starts flapping its wings. So when it gets bigger, it gets more narrow, right? The numbers are increasing. Like if I put it on 6, that means all these Y values are increasing 6 times as fast. So it's going to get taller faster. Makes it more skinny. And then if I get below 1, that's when it gets wider. Here's just the parent function right there, and this makes it a little bit wider. And if I get to 0, well, times 0, that's going to be y equals 0, horizontal line. But if I get negative, that's opening down. And so just need to remind ourselves what these values do. So when we go to here and start doing these functions, we can properly identify. So when it says describe the transformations, that basically means how does the graph change? Sometimes just decoding what the directions mean could be a challenge. So we want to know describe just means what's changing about it. Describe the graph changes. And so for this first one, we're going to do the composition and then graph it. So f of g of x, so we're going to take g, x minus 1, and we're going to evaluate that into x squared. So we're going to have x minus 1 squared. So what does that graph look like based upon what we just saw? What direction is it moving and how much? And everybody says? Right one. So our vertex is now right there. Instead of at the origin, it is now here. Now we should know how to actually graph a parabola without a graphing calculator or anything. So remember, it's x squared, right? So 1 squared is 1. So if you move 1 over, you should go up 1. Both directions. Negative 1, positive 1 are both squared equal 1. If I go over 2, 2 squared is 4. So if I go over 2, it's going to be up 4. Negative 2 squared is also 4, up 4. And if I go over 3, up 9. Good. So I can draw a very, very, very accurate parabola without a calculator. And if I'm just sliding over or translating over left or right or up and down, it should be very accurate. Okay. And then it does say, describe in words what happened. You could say it's a translation. Of 1 unit right, or something of that nature. Let's look at B, and this time H, which is 2x. That's going to go inside x squared. So we're going to have 2x going into x squared. So we got 2x in parentheses, mind you, squared. So we get 4x squared. So similar to what we just did, we'll start at the origin. We don't have the minus 1 anymore. Right? But it's going to increase 4 times as fast. So if we go over 1, usually it's up 1, but now it's up 1 times 4, so up 4. And then same thing, it's symmetrical both sides. So even if there's a 4 in front or some number, we can still sketch these accurately, is my point. We shouldn't have to estimate it and kind of, I think it's this, or do something like, way too wide or something. And then the next one would be 2, if you square it, is 4, right? But times 4, let's see, it would be what? 4 times 4 is 16. It'd be way off the chart. So that means I need to, if be, here's 2, so that'd be way up here, so I just got to be careful and keep it really narrow. It shouldn't cross over the 2, right, because it's not going to reach 2 till you get to 16. Right, so it's way up there. Okay. So this had an effect of compressing it by a factor of 4. All right, try the last one. See how that goes for you. This is g of f of x. So take f of x, which is x squared, plug that into g. Let's do the color. And we have g f of x, which is x squared, right? If I plug x squared into g, the x becomes x squared. So what kind of change is this? What kind of change is this? All right, moving down 1. And still the same thing. There's no longer a 4 in front, so going back to, okay, move over 1, 1 squared, up 1, both sides. Over 2, 2 squared is 4, up 4. And so on. So compared to the first one, everything has just moved down 1. There we go. And this would be a translation of 1. Okay, so good. And make a note of that translation 1 unit down. So write that out as well. All right, and then let's flip it on over. And this is time for you guys to do a little practice. So often in math, you do learn some sort of problem, and then you learn it in reverse. So we have a graph, and you need to come up with a table. On the very first part, we had the table, and you had to do the work already. So just kind of doing this in reverse. So using these functions, I'll give them to you. Go ahead and fill out all 3 columns, and then once you have the last column filled out, you graph that composition on the empty one. And definitely reach out to each other to help one another out. Alright, so we could do -4. Start there. I color coded this just to make it a little bit easier, so f of x is red. -4 should get. We move to -3, we get -2. Move to -2, we just get 0. Okay. I'll do a little bit of the g of x. So starting at -4 over here, we have +2. And -3, we get +1. Then keep on moving, get 0. So how do we find the h of x, right? The composition. So we're taking 2, and we're looking at where that is for as an x value for f of x. So if I go to 2 and I look at f of x, I can see I get 1. And I get 1. That's going to be 0. And I get 0. And that's going to be 1. And then I can go down here and use the x and the h of x, right? So use these coordinates, -4, 1, -3, 0, and -2, 1. And I'm graphing those here. -4, 1, -3, 0, and -2, 1. All right, so take some time and finish that up, and you can connect all these when they're finished and then compare with one another. Look at that, see if you got the same numbers. Yeah, and really you're just taking the g, all those x values, right, as an x value, and just looking where it intersects with the f of x graph, right? So the answer, or the y values, now become the input for the x values here. All right, so let's move on, and we're almost done. All right, so go ahead and start by finding f of x, so f of g of x and g of f of x for each one of these. And we're going to look at graphically. I'll put up the graphs for you so you don't have to do it yourself. But start by just finding f of g of x. What does that simplify to? And then also g of f of x. And we're going to look at what these actually look like geometrically. So going back to the translations and all that good stuff, we're going to see what these look like. All right, so for A, the first one, you saw that this simplified. All this, the cube root with a cube, just simplifies to whatever's inside. And then we have the +1 -1, so we just get x. Right? And over here, the inside, which is x cubed -1 + 1, just simplifies to cube root of x cubed. So we get x again. So this is one of the rare instances that the g of f of x and f of g of x actually are the same exact thing. So when they are the same, what does that mean? So that's the question we want to answer. So since, I'm going to write this all the way out. So since these two are the same, f of x, g of f of x and g of f of x, write it all the way out, since they're equal to each other, then what is true? And like, well, they're both the same. Other than that, you can't really tell a whole lot algebraically. So that's why they wanted you to graph it up here and say, well, look at a graphing utility and just see what happens. So that's what I'm going to do right here. Right here, you can see if I graph this one, there it is. Looks like a cubic function. And if I graph this one, look at that. You can tell that they are reflections of one another. Right? So we did translations earlier. Here's some reflections. So when this occurs and both of them come out to equal x, right? Both versions, this will always happen. There's actually a reflection on the line y equals x. So this answer right here is actually a line of reflection, a diagonal line, y equals x. And what does that all mean? You could say then f and g are inverses of each other. So they completely undo one another. And so what does that mean is that if I get an answer, if I plug in 2, 2 cubed would be 8, 8 minus 1 would be 7. If I plug that back into the other one, 7 plus 1 is 8, cube root of 8 is 2. They undo one another. They're inverses of one another. So no matter what value of x I pick, that will always be true. So one's kind of like a forward direction of, doing something to it, and the next one is can completely undo it and do the whole thing backwards and end up at the same number you started with. Right? So that is what an inverse is. So anytime you end up with the same value, which is going to be x, that's what the case is. So over here on the right-hand side, once you did this, right, we ended up with just x plus 1 and minus 3, which equaled x minus 2. And then here We ended up with x minus 9 plus 3, which is x minus 6. So therefore, they are not equal to each other. Right? F of g of x and g of f of x are not equal to each other. And f and g are not inverses. Now, just for being thorough, well, what does it look like graphically when it's not an inverse, right? So we know inverses will look like this, right? Goes right through the origin, y equals x. So if we have something that's not an inverse, you can see here, well, they still have a mirror-like reflection quality. It just doesn't go through the origin, right? So if I actually made this minus 1.5, yeah, there is a reflection, but yeah, not through the origin. It has to be through the origin to be considered inverses, right? And if you tried it numerically, if you try to plug a number into here and then plug it into the second one, you would not arrive at the same x value, right? It would not do that. All right, so that's all for today. All right. There are some applications. We'll do these first thing tomorrow, just these two problems, and then on the homework tomorrow in class you can do all the word problems. So today just go all the way up to the word problems with applications. If you want to keep going, totally fine, but you don't have to.